Yo, what's up everyone? Welcome back. Patrick here, moving on to a couple of examples dealing with L'Hopital's rule. So we got these three limits to solve here. And one thing I want to note is notice that the last two limits, they're generalized. So notice that instead of numbers, we have a base b there. And then we got this constant m, this constant n. Basically, b, m, and n are just any real number, any constant. I wanted to generalize these last two limits, but this first limit here, notice we're dealing with numbers everywhere. We got a base of 2, we got a constant of 5 there. Okay, so these last two limits are going to be in a little bit more of a general format. So let's start with this first limit. We got the limit as x approaches 0 of 2 to the power of 5x minus 1 over sine x. So first thing to notice is we can't do a direct substitution. So if we plug in 0 for x, notice we'll get 0 in the denominator, and then we'll have 0 in the numerator, because 2 to the power of 0 is 1, minus 1 is 0. So notice it's in indeterminate form if you do a direct substitution. And because it's in this form, 0 over 0, we can actually do we can use L'Hopital's rule. So we could take the derivative of the top. So notice we got 2 to the power of 5x minus 1. Now the derivative of minus 1 is just 0. What's the derivative of 2 to the power of 5x? Well, just in general, let's do a quick review here. If I got a function where I have a base to the power of another function, notice we got 5x here, which is another function. It's not just x by itself. The derivative of this is going to be that function written out as is times ln of b times g prime x, like that. Okay, so applying this here, the derivative is 2 to the power of 5x times ln of 2, ln of the base, times the derivative of 5x, which is 5, over the derivative of sine x is just cos x. Right? So now if we plug in 0 for the x values, notice that we'll have 1 at the bottom. Notice now we could do a direct substitution because we're going to have 1 at the bottom there. And then up here, we're going to get a certain value. We'll have 2 to the power of 0, which is 1, times ln 2 times 5. So we'll have 5 ln 2. Right? So that ends up being the final answer as an exact value. 5 ln 2 is the answer to that limit right there. Okay, so let's write out that answer up there. We got 5 ln 2. And then number 2, we got the limit as x approaches 0, b to the power of x minus 1 all over sine x. So notice again, can't do a direct substitution because we're going to have 0 over 0. But because it's in that 0 over 0 form, we can use L'Hopital's rule. So taking the derivative of b to the power of x, we'd end up with b to the power of x times ln of b. Right? And then it's just an x here, so it's like multiplying it by the derivative of x, which is 1, so we don't have to write that 1. And then the derivative of sine x is cos x. And now notice we could plug in 0 for all the x values. We plug in 0 here, we'll have 1 times ln b, which is just ln b, and then cos of 0 is 1. So the answer ends up being ln of b. Right? Moving on to number 3, we got the limit as x approaches 0 of b to the power of mx minus 1 all over n sine x. So this one's a little bit more complex because we have a function. It's kind of like this here. Right? We got 2 to the power of 5x, we got b to the power of mx, and then over here we got n sine x. So first off, notice we can't do a direct substitution. Again, we're going to get 0 over 0 like we did for the last two. So let's apply L'Hopital's rule. So we'll have the limit as x approaches 0. The derivative of b to the power of mx, it's going to be b to the power of mx times ln of b times the derivative of mx. The derivative of a constant times x is just that constant m. All over the derivative of n sine x is going to be n cos x. right? That constant stays in front and we just derive sine x like that. So now we could plug in 0 for the x value. So we would plug in 0 here, that would end up being 1. So we'd end up with m ln b over n cos of 0 is just 1. So it's just an n that we're left with at the bottom. Right, so that ends up being the answer for this right there. So you could plug in any number. So if we had like the limit as x approaches 0 of, let's say, 10 to the power of 3x minus 1 over, let's say, 5 sine x. Okay, it's just going to end up being this here. So it's going to be the m, which is 3 in this case, times ln of 10 over the n value, which is 5. Right, this is a more general format. Okay, so in all three of these limits, they were all in that 0 over 0 format. After a direct substitution, they were in indeterminate form, so we could apply L'Hopital's rule, and then we get actual expressions for the limit.